Hello all, welcome to the second session of the second series of free training. In today's session, we will be discussing on application performance monitoring. And quickly, let's check today's agenda. Drill down to the problematic elements in your application code. Monitor code flows across applications via distributed tracing. Gain code level visibility with thread profiling. Visualize dependencies in your application architecture with automated service maps. Before discussing the topics in the agenda, let us start off with why an application's performance monitoring is needed. Imagine a user is accessing an e-commerce website and purchasing from the online store. On completion of the selection of items, they are attempting to place the order. At the time in the payment portal page, they encounter issues like the portal taking a long time to load or getting redirected to a different page or showing some error codes, etc. So this could lead to a loss of potential customers from accessing the application and leading to a loss of business. And for the developers who are working in this web application are unsure of the root cause. So in this scenario, the demand for using an application has increased, which has also led to the complexity in its development. Hence, it is necessary for the developers who are working in the application to make sure that the website is bug-free and handle the load in the application's database to ensure providing a better service to their users. These are the Gartner's 5 dimensions of APM functionality. Let us see one by one. The first one is end user monitoring, which helps us to understand the behavioral aspect for an user while interacting with a website or web application. The second one is application topology discovery and visualization, using which the various applications running on different servers and network devices within the network infrastructure can be discovered and map their dependencies. Third one is user-defined transaction profiling. It is a functionality that assists in tracking the user activities in an application across all of the components. The fourth one is application component deep dive. It is the ability to analyze and understand the behavior of the different component within an application. And the last one is IT operation analytics. So using this option, you can get the necessary information to understand the behavior of the environment through reports and analytics. Let us see some of the benefits of modern versus traditional approach in building an application. The first one is application availability. We are aware that there is a dependency on application in our day-to-day life. So with the increasing dependency on applications and wide usage of it has made the application to be always available for the users. So a group of microservices are built instead of a large monolithic application. The development of technologies like containerization and load balancing has helped the organization to achieve this high availability. The second one is cost reduction. With the advent of cloud computing capabilities, organizations no longer need to spend more money or to build large infrastructures and thereby saving their capital expenditure. The third one is compliance tracking. So every applications are developed based on a particular standards. So depending on the industrial standards like HIPAA for healthcare, FIPS for USA government, we can easily track if an application follows those standards or not. And the last one is operational efficiency. As discussed in the last session, using the dependency mapping, you can easily identify the faulty component of the application quickly in a single click and identify the down applications much faster for instance diagnosis of the problem. So far we have discussed why application performance monitoring is necessary. In Applications Manager, the performance monitoring tool is called as APM Insight. The APM Insight will give you an understanding the way your application is behaving for the end users who are accessing it. By a complete end-to-end transaction monitoring across your entire web application will help you to avoid any performance issues. Also, you can analyze the root cause of the problems much faster by performing any first level troubleshooting. These are the supported technologies in APM Insight: Java, Node.js, .NET Core, Microsoft .NET, PHP, and Ruby Rails. Let us see the functioning of how an APM Insight. APM Insight is an agent-based monitoring tool. The remote agent needs to be deployed in the machine where your application server is running. So this agent will perform the task of data collection, data acquisition, and data transmission. The agent residing in the application server uses bytecode instrumentation method to collect the data from the target application and sends it to the application's manager at a fixed time interval. Moving to our first topic in today's agenda, drill down to the problematic elements in your application code. Let us see some of the factors that can affect the performance of an application. The first one is response time. When a transaction is made by an user in the web application, the request is sent from the application layer, which travels through the transaction and network layers and hits the application server. And this request is served back to the end user. In case of slow connection to the web application, can lead to a network traffic and the transaction consumes longer time, which can lead to a poor response time. The second one is application code. An application is developed using certain technology which have or which can have a large number of bugs affecting the functions and performance of the application. So bugs in the code can cause exceptions that might result in the transaction execution failures, and stack trees can be used to identify these code issues that can improve and fix the application code. The third one is memory. High usage of the web applications and not optimized application at the code level may cause high consumption of the memory from its allocated space in the machine, leading to memory leaks and out of memory. And the last one is database. For instance, the database calls and queries pertaining to a specific transaction could become highly loaded, affecting the performance of the application. Hence, for the developers working in the application can be dependent on this APM Insight monitoring tool to keep an eye on the factors that are affecting the performance. So this is about the configuring key transactions. But before moving into the next slides, we will see of the APM Insight working through an GUI. So if someone of you are already using the APM Insight tool, the GUI has been recently revamped in our latest version. So this is the new GUI of the APM Insight Monitor. So firstly, we will discuss about some of the key performance metrics or key performance indicators like the AppDeck score, the response time, request, throughput, and exceptions in detail. Under the Overview tab, you have the AppDeck score. So the AppDeck score is a standard which is used to measure the possible satisfaction rate of the end users on a scale of 0 to 1, where 0 indicates that no users are satisfied and 1 indicates that all the users are satisfied. This is calculated based on the transactions response time. That is, the sum of the transaction, or sorry, the sum of the satisfied count or the transactions and half of the tolerating count over the total samples that are collected. Based on this results, it is categorized as satisfied, tolerating, and frustrated. A transaction is marked based on this AppDex threshold, which is defined in seconds. Any transaction whose response time is within the threshold is marked as satisfied. The ones which are up to 4 times the threshold are defined as tolerating, and anything over that is frustrated. The default threshold value in is 2 seconds, which can be altered based on one's requirement. The next one is the response time. You can see the average time taken for the transaction in the application. This can be viewed at the application and also the individual instance level. The next key metric is request. The total number of transactions that was processed by the application can be monitored under the request. The fourth one is the data throughput. So under the throughput, you can view the rate at which the transaction requests were made by the user and the rate at which it was served back over a network. And the last one is the exceptions. So some of the transactions that are not fully processed in the application are counted under fatal and warning severities. So this overview tab is a simplified dashboard page which gives you an overall summary of the web application based on the key performance metrics that we have just discussed. So based on that, you can view the response time broken by the components, the transaction list, which has the data of the AppDeck score, the errors, the HTTP errors. If there is any exception count and it's split up, the top slow traces of the transactions that are made in the application, and the top 5 transactions by the response time. And if there is any exception traces, we can monitor its recent 5 exception traces. Moving on to the next tab, which is the transactions. So under this transaction tab, you can view the transaction details, which has consumed a longer time, and some of the frequently accessed transactions get a tier-wise breakdown of the transaction time from the application level to the individual level. You can also view the various transactions that are running as web transaction, background, or errors. So here you have the list of all the transactions that were made in your web application. When I click on the individual transaction, it will take me, or it will show me, the recent 5 traces of this transaction, the slowest traces of this transaction, the response time broken by the components like the application code, the overall response time, and if there is any application server components split up, request throughput, and the data throughput. So this can be viewed either in a graphical or tabular representation. So here under the tabular representation, we have the number of requests that were processed in the application, the errors, which is nothing but the percentage of errors that has occurred within the transaction, the response time. Here we have the average, minimum, and the maximum time taken for the transaction to respond within the application, which is calculated in seconds. The bytes in and bytes out, which is nothing but the throughput, where you can monitor the average amount of bytes that are received and sent from the transaction within the application respectively. And the last one is the CPU, which is nothing but the amount of time taken by the CPU to run that particular transaction, which is in milliseconds. So apart from the user made transactions, some of the transactions could be running in the background of the application, which can be viewed under the background tab. So when an user is making any transactions in your application, there could be some transactions that are running in the background. So that will be separately tracked. So just similar to what we have monitored for the web transactions, you can get the recent of traces of the background transaction, the response time taken for it, the application server component split up, then the transaction response time and its throughput. So this can be viewed for the individual transactions. So if you go for a tabular view, there would not be any throughput monitored for the background. But apart from that, you can monitor if there was any errors or the number of requests, the response time taken for the background transaction, etc. Under the errors tab, you will have the or you will only be monitoring the errors that has occurred when an user is making any transactions. So using which based on the errors, you can try to identify which particular transaction has the maximum number of errors, and you can try to get their individual data like the slowest 5 traces of that particular error transaction and the response time taken by the components like the HTTP call, etc. So using all this data, we can try to enhance the performance of the application. We have seen the web background and error based transactions, but some of you might be finding some transactions to be monitored with high priority, or some of the transactions could be critical to you. So we have an option called configure key transactions, where you can try to select some of the key transactions from the list which is available here, and they will be separately monitored under the key transaction tab in this page. So this is irrespective of whether it is a web transaction or a background transaction or an error transaction. Whatever transactions are selected for monitoring will be available and monitored under the key transactions page. Moving on to the database tab here. In the recent builds, we have enhanced this database tab, where you will have all the database operations that are monitored. And apart from this, some of the database operations could be based on select queries or update queries or insert queries or delete queries, which can be separately viewed under the each tabs, that is select tab, update tab, insert and delete tabs. So here you can get a detailed performance metrics to identify if there is any slow database calls, their usage, and the overall performance of the database can be explained in detail under this graphical and tabular representation. So by clicking on the individual database operation, you will be able to view a list of web transactions that were performed by that particular operation, which allows you to identify the root cause of the performance slowness. So here in the tabular view, we can see the total request, which is nothing but the number of times the database operation has run in the application. We can monitor the errors, which is nothing but the percentage of the errors that were made by the database operation. And when you go to the graphical view here under the database operation, you can view the recent 5 traces that were available for the database operation. The caller, that is the user who has invoked this particular database operation, and the database operation by response time and throughput can all be monitored under this database tab. So here you might find something interesting, that is some of the database operations will have question marks. So this is nothing but some of the data values in the database operation can be crucial, or to maintain the credibility, we have obfuscated the values in the database operation, so that in case if this option is being disabled, will give you the real query. And however, we will recommend you to enable this option. That is, if there are queries getting executed which has using the confidential parameters like credit card number or passwords, will not be visible to the other user. Moving on to the traces tab. So under this particular tab will provide you with a deeper insights into the individual transactions that are running with your application. So the transaction traces are the prints of the transactions made by the user in the application that helps you to identify the issues and analyze the root cause of the issue. So in general, there could be multiple codes executed in an order which follows an execution method. So here under the traces, you can monitor the execution flow of a transaction, which will include the method calls which was involved, the database queries, and any exceptions. So when a transaction exceeds the specified threshold value, it is captured as a trace. So here, depending on the response time, I have selected an transaction. So where I can see that this particular transaction has a total of 18 method calls invoked and 245 SQL queries. So we can view it all the method calls that were invoked for this particular transaction under the trace details. You can either view it for the method calls or only for the the SQL queries that were involved. So here we will have all the transactions that were made. There is an option here to toggle between the suspected slow metrics. That is, when I click on this suspected slow metrics, it will help me get the details of the method calls that were much slower. If I go to the tabular view of this traces, I will be able to monitor the response time taken for the trace of the transaction within the application, its external calls, the exceptions, the SQL time, the CPU time, and the distributed calls. Also, you will be able to get the response code, that is the HTTP code, and the method, if it was a get or the post method involved for that particular transaction. Here, under the summary tab, we will be able to get the HTTP response code and the method, the slowest method calls that were involved in the transaction and its duration and the percentile, the request parameters, and the external calls. So as discussed, under the trace details, it will display all the methods that are running and their duration in seconds. You can also search the option or the method call specifically if you want and get an analysis about that. So using this suspected slow metrics, you would be able to identify the slow metrics which will help you to improve the overall performance and identify the methods that are executed slowly. Under the remote external calls, you will be able to monitor the name of all the external calls executed and the number of times the external component is called along with its execution time. So moving on to the JVM tab. So this JVM tab will be specifically available only for Java-based applications server. That is, if you're adding any APM Insight monitor, which is based on the Java-based, only for that you will be having this JVM tab. So under this JVM tab, you will be able to monitor the application code that is running on your JVM. Here, you can monitor the key metrics that are important for your Java application, which will help the developers to gain more details into how the various resources impacts the Java application performance. So for example, you will be able to monitor the CPU usage, the JIT, and that is nothing but the just-in-time compiler, the runtime memory, the classes. So the Java CPM usage indicates the CPU of the Java on your server. The runtime memory, it will be able to help you out with the total memory reserved for the Java virtual machine. In under the JIT, you will be able to monitor the time taken for the JIT compiler to optimize the classes loaded into your JVM. And the other performance metric, like under the garbage collector, you will be able to monitor the mark sweep, the PS scavenge, the collected objects count, etc. And under the threads tab, you will be able to monitor the collection time, that is the timestamp will be available, using which you will be able to monitor the current thread that was recorded. You can monitor the peak threads count since the JVM started or the peak was reset. Then the live threads, which is nothing but the number of live threads that are currently running, and the collection time, all these can be monitored of the JVM under the JVM tab. Under the configuration tab, you will be able to monitor the uptime of your JVM, the number of processors that is used for it, and the general information about the JVM, like the JVM name, its version, the vendor, and also you can get the agent installation path and when it was started. So moving on to the exceptions tab. So here under the exception, it will help you to monitor the application by giving a detailed insights into various exceptions that are involved in the application. In this tab, you can identify the different types of exceptions and the errors that are causing the performance issues in the application. So here we will be able to monitor the top executions, where you can get the name of the execution and the number of times that particular execution has occurred in the application. And under the recent five exception traces and recent five error transaction traces, you will be able to identify which transaction has got the maximum exception and along with its count that can be monitored. And you will be able to get the name of the transaction and the error code that has occurred for that particular transaction. So these are some of the uh, important metrics that are monitored in an APM Insight monitor. And our chat panel is available, and you can raise your questions in case if you have any queries with the discussions that we have made till now. So let us go back to the presentation. So we had discussed about this configuring the key performance transactions. So by now you will be more interested on the monitoring the key business transactions to monitor your entire performance of the application effectively. So in this slide, we shall see on configuring the key transactions of your business operation. So there could be a high volume of activities made in the application, and all the transactions would be captured, among which you can select the key transactions that you want to monitor in it and set the threshold based on the response time of the transaction. Moving on to the next slide, monitor the code flows across applications via distributed tracing. In a microservice architecture, it is necessary to monitor the transactions made between two or more applications or services. So with the distributed tracing feature, you can trace all the data that you're looking to monitor between the applications. Let us understand how tracking is done in the distributed tracing. When an API request is made by an application to another application, the APM Insight will add an HTTP header containing the metadata that is required to track the request. If the APM Insight is enabled in the other application, it will process the HTTP header and return the tracking information to its caller via the response headers. In case if the other application in turn calls another service, the header propagation would continue and traces all the paths that are taken by the original application across the distributed system. So using this data, we can monitor the start time when the transaction was initiated, the response time taken for the transaction to respond within the application, and the name of the transaction and the applications. So you can also monitor the traces made from one application to the another application, and this enables you to monitor the calls made between the two applications and narrow down their problem. The next another feature is auto scaling in APM Insight. So in a cloud environment, whenever an application automatically scales up, a new instance is added. However, when these applications are scaled down, these newly added instances will become unused and are still retained. So this leads to the license being consumed by the unused instances, resulting to the new instance not being added for monitoring. Hence, with the help of auto scale mode in the APM Insight, you can overcome this scenario by automatically unmanaging or deleting the unused instances in the cloud environment. Next, we shall discuss on gain code level visibility with thread profiling. Here, let us see the need for a thread profiling under the topic eliminate issues in problematic code. So, as you are aware, stack trace represents the movement of an application during the execution of a program. When Java applications throw an exception, stack trace get logged within it. When a program is executed, memory is often dynamically allocated in two places. One is the stack and the other one is the heap. So the memory is continuously allocated on a stack but not on the heap. Hence, in this scenario, the thread profiling will help you to identify any issues in your code stack, and all the thread profiles are collected in a time frame and are listed along with their thread count and CPU and memory details. So each and every thread profile will consist of a list of threads that were running when the application was profiled. So there are two types of thread profiling. One is the scheduled profiling and the other one is the on-demand profiling. Moving on to the last topic of the today's presentation, visualize the dependencies in your application architecture with automated service map. So what is a service map? In order to get a complete overview of the application infrastructure along with its connection to the other dependent resources, we use a service map. So the purpose of using a service map are to easily identify the status of application and its instances, monitor the key metrics like the response time, the throughput, and the status of connection, then detect in case of any issues and troubleshoot your application problems before your customers are impacted. So here under the map view of the service map will provide the way of analyzing the topological view of the application, and along with its instances are represented in the central node. So we will see something about the reports, that is managing and data analysis are important factors of application monitoring. To achieve this, we use the reports. So let us see the different report types that can be used for the APM Insight monitoring. So here under the report tab, we have the reports like the trend analysis report, we have the forecast report, we have the inventory report, the schedule report, the availability report, health report, and attributes report. Let us see one by one and let us see how to use these reports for getting the data of your APM Insight. First, trend analysis report. So here under the trend analysis report, I will be choosing the APM Insight monitor. Under this, the first one is the at a glance report for the APM Insight. Okay. So here, the first one is the at a glance report. So using this report, you will be able to monitor the performance of the selected monitors and can compare it in a single view. So here, when I click on the individual metrics, I will be able to I will be able to get a detailed information about the various metrics that are monitored in the APM Insight in a single view. So when I click on the individual metrics from here, we can monitor the behavior of that particular metric in a selected time period. For example, if I'm choosing the last 7 days data for the metric response time, here I can view the maximum and the minimum values that were collected for the transactions response time. So these are all the hourly average data collected. So at each and every polling, the data will be saved in the database as an hourly average, which will be then available in the reports. So this can be selected for the other metrics as well, like the ACDEX score. If you want to monitor it for the frustrated or the satisfied or the tolerating users, then you can get the report for the runtime free memory, runtime total memory, and if there were any errors in the transaction. You can also get the request throughput, which is nothing but the data bytes in and bytes out that can be monitored here. Get a report of the maximum and the minimum value that were calculated for the throughput in the selected time period. The next one is the downtime history report. So this will gives us the downtime and the uptime chart for the time period that was chosen, and also the downtime history for that particular monitor across all the time periods. You can view the summary details of any scheduled downtimes and unmanaged time as well. So this will give you more clarity in knowing the monitor's exact downtime. So you can also add some notes on why that particular monitor was down under the reasons section to get a clarity about the downtime. The next report is the summary report of the monitor. So here you will be able to get the summary of all the reports for that particular monitor, like the availability report, the AppDex in the frustrated, the satisfied. All this can be summarized for that particular monitor. So this is available for all the time periods, just like what we have seen in the previous reports. So depending on the time frame that you're looking, you can try generating these reports. So individually, apart from all these the reports, individually, if you're looking for the latest trend, what is happening for any specific metric in the APM Insight monitor, you can try to generate for the reports for them as well. So that will be available under the trend analysis report, which you can use it for any analyzing the data of your application. So next we will see about the forecast report. Okay, so using the forecast report, it will help you in predicting the future utilization of that particular data based on the current data which is collected and the current utilization trends, and balance the cost in case of any cost computing needs is required. So this forecast report is of two types. One is forecast report by growth trend and forecast report by utilization. So we will see one by one. The forecast report by growth trend. So this report, or generating this report, is based on the current utilization statistics and will predict the growth in utilization in future based on the present statistics. So for example, I have generated a report for the AppDex metric. So these are the last, based on the last 15 days of data, which is available. So using this data, you can try to get it for the next 2 months. That is, like you can try to get it for the month until July. If you want, if you are selecting 5 month report, you can get it up till the October. So this is all predicted based on the uh, reports or the based on the values that are currently collected for the APM Insight monitor. So here you will be able to get the actual data which are collected for the AppDex score. So depending on these data, actual data which are all collected, you will be able to forecast or predict the data in the near future, or like, for example, in this report, based on the data collected until the 11th of May, you will be able to predict how the AppDex score can be for the 12th of May or 13th of May and going forward. So as mentioned, this is of two types. One is the forecast report by growth trend, and the other one is forecast report by utilization. So that will be available only for the percentile data. That is, for example, now for satisfy, here you will be able to use or generate the forecast by utilization. So this is nothing but this is similar to the growth trend. So using this report, you will be able to get the reports based on the current utilization statistics. But it also notifies when the utilization level reaches an extreme high, that is 20, 80% or 90% of the value. So that can be fetched from this forecast by utilization. So this report is generated only for the attributes which are measured in the percentile scale. So apart from this, you will also have the forecast report by growth trend, which is predicted using the actual data which is collected, and which will help you understand how the data could be or how the behavior of that particular metric could be in the future. And apart from this, we have the inventory report. So using this report, you can try to get the details about the APM Insight monitor, like when it was added, what is its current state, like is it in managed state, and get its details like the resource ID and etc. So let us have a quick recap of what we have discussed till now in the APM Insight monitor. So we have been discussing about some of the important or the key performance indicators like the AppDex score, which is nothing but it is a standard which is used to measure the overall user satisfaction, the response time, which is nothing but the average time taken for the individual transaction to happen within an application, the total number of requests that was processed in the application, the data throughput, that is nothing but the uh, data or the transaction requests which were made by the user, and the rate at which it was served back by the application server, and the fatal and the warning exceptions. So we have seen that we will be able to monitor the overall transactions happening under the web transaction tab, get the individual transaction details, and if there was any background transactions apart from the user made transaction can also be monitored. And for prioritizing some of the transactions, you can mark them as key transactions and monitor them separately. And under the database tab, you will be able to monitor the slowest database calls, their usage, or the overall performance of the database can be explained under the database tab. Here you have the total requests, the errors, And if you want to view them separately, like the select database operations or update database operations, that can be viewed separately. So through which you will be able to get the details specifically to that individual database operation only. And here under the traces tab, you will be able to monitor the traces, which is nothing but it will provide you the snapshots of the individual transactions that were running within your application. So when I click on the individual transaction, I will be able to get the method calls and the SQL statements that were invoked for that particular transaction, view their SQL statements, so that using this I can identify the queries. If it has taken a longer time to run, the number of queries that were executed for that particular transaction can be monitored. So in case if there is any exceptions happening, that can also be monitored using the stack trace here. And I can get the response code, that is the HTTP response code, and the method post or get methods that was used. Monitor the key performance metrics of the JVM and the exceptions. So exceptions are nothing but uh, it will provide you the details into the insights of the APM Insight of the application. So here you will be able to get the different types of errors and the exceptions that are causing any performance issues. So using all these data collectively, you can try to work on, like the developers can work on all these data. They can easily identify if there was any issues happening for that particular exception, and enhance those metrics based on the data which is collected. So we have seen a quick recap of the presentations that we have seen today. Thank you everyone for your valuable time.